All right, welcome to this explainer. Today, we're jumping right into what I think is a pretty massive paradox in the tech world right now. As artificial intelligence models get more sophisticated, more nuanced, and honestly just a lot more human-like in how they chat with us, evaluating them is quickly becoming our absolute biggest challenge. We're literally building machines that are outgrowing the very tests we originally designed to measure them. So I want to pose this question directly to you. How do you actually grade an artificial intelligence? Think about it for a second. If an AI is, say, writing a creative sci-fi story or trying to explain quantum physics to a 5-year-old, how on earth do you give that a definitive score? Our traditional grading systems are basically breaking down in real time because they were built for a completely different era of AI. Okay, let's dive into this. On the left side here, we've got the old way of doing things. These are rigid, multiple-choice tests, like the MLMU benchmark. For a long time, this was exactly how we tested models. Just A, B, C, or D. But look on the right. This is how we actually interact with AI today. It's all fluid, multi-turn, open-ended conversation. And the research shows a huge disconnect here. A model might totally ace a multiple-choice test, but then completely fail to follow a basic real-world instruction in a chat. Those old benchmarks just don't capture how we actually prefer to communicate with these systems. To try and solve this, researchers initially went straight to the gold standard, which is human evaluation. They literally hired expert graduate students to sit down, read through AI responses, and judge which one was better. But look at this number, $35 an hour. That is what it costs to pay human experts to evaluate just a handful of prompts. When you've got brand new AI models dropping every single week, relying entirely on human grading is just impossibly slow and way too expensive. Section 1. The Human Evaluation Bottleneck. Why Old Tests Fail. And this brilliantly illustrates exactly what we're up against. We've hit a massive bottleneck, and we urgently need a scalable way to measure these incredibly complex capabilities. This radar chart is from a new benchmark called MT-bench, and it uses open-ended questions to test conversational ability. Notice how it's testing a really diverse set of skills: coding, roleplay, math, humanities. Basic tests miss all of this. It's like a giant puzzle, and you can see how different models excel in totally different areas. We need a system that can evaluate this whole shebang simultaneously. Section 2. Enter the AI judge. Automated referees. So the proposed solution here is actually kind of elegant. If humans are too slow, why not use advanced aligned AI models to act as our surrogate judges? The researchers put it perfectly. LLM-as-a-judge is a scalable and explainable way to approximate human preferences, which are otherwise very expensive to obtain. By having an AI judge another AI, we completely solve the speed and cost issue. But the real kicker is that word explainable. The AI doesn't just spit out a random score. It gives you detailed written reasoning for its grade, pointing out specific flaws, just like a human teacher would. Now, the researchers laid out 3 main ways an AI can actually do this. First up is pairwise comparison. Just picture the AI as a referee in a boxing match. 2 different chatbots answer the exact same prompt, and our AI judge decides who wins, who loses, or if we've got a tie. Second is single answer grading, where the judge just looks at one answer in isolation and scores it. And third is reference-guided grading. This one is super useful for math or logic, where the AI judge is actually handed a verified answer key to compare the chatbot's work against. Section 3. Blind Battles in the Arena, the Ultimate Test. Of course, all of this raises a massive question. How do we actually know if our AI judges are getting it right? Well, to validate them, we have to gather real human preference data. Imagine you log into this interface shown here. This is Chatbot Arena. It's a crowdsourced platform where you type in a prompt, and you instantly get 2 chat windows side by side. The catch? The models are completely anonymous. You just chat with both of them to see how they handle your real-world questions. The rules of this arena are super simple. The models stay anonymous, you chat side by side, and then you, the human, cast a vote for the answer you liked best. Over tens of thousands of these crowdsourced votes, we build up an incredible baseline of what humans actually prefer. And this is the exact data we're going to use to test if our AI judges are truly accurate. If we put an AI judge in the exact same scenario, does it agree with the human consensus? Section 4. Fact-checking the AI, the safe framework. Let's move to and see how this builds, because before we can trust these AI judges, we have to talk about hallucinations. How do we know the AI judge isn't just getting tricked by an answer that sounds confident but is totally made up? The researchers built something called the Search-Augmented Factuality Evaluator, or SAFE. It basically turns the AI into a relentless fact checker. Step 1, the AI splits a long response into individual facts. Step 2, it actively runs multi-step Google search queries for each claim. Step 3, it acts like a detective, reasoning through those search results to see if the real world actually supports the fact. And the efficiency here is absolutely wild. Get this. Running that automated SAFE framework is more than 20 times cheaper than paying human annotators to fact-check the same text. 20 times! It's scalable, it's systematic, and it literally uses the entire internet to verify claims before it passes its final judgment. Section 5. AI blind spots and biases. The flaws of the machine. Now, if you're sitting there feeling a little skeptical about a machine judging another machine, you are absolutely right to be. We have to play detective here. The researchers found some glaring flaws, starting with position bias. This is basically the AI judge's tendency to automatically favor whichever answer it reads first, completely ignoring the actual quality. It's a really strange blind spot, and researchers think it happens because of how these models are fundamentally wired to process text left to right. Now, what's really interesting about this slide is just how easily the machine is manipulated. On the left, the AI judge reads Assistant A first and goes, yep, Assistant A wins. But look at the right side. The researchers literally just swapped the physical order of the exact same text, putting Assistant B first, and the AI's verdict completely flips. It suddenly decides Assistant B is better. It was literally just picking whatever was in slot number 1. No way, right? And then there's verbosity bias. AI judges have this weird, almost funny weakness for unnecessarily long, wordy answers. The researchers ran this thing called a repetitive list attack. They took a great, concise 5-item list and then forced a model to just rephrase those exact same points to make a bloated 10-item list with zero new information. And it worked. The AI judges were tricked into thinking the bloated answer was better simply because it was longer. Thankfully, researchers figured out some clever ways to mitigate these blind spots and keep the AI acting like a fair referee. To fix that position bias, you just run the evaluation twice, swapping the order of the answers, and you only declare a winner if a model wins in both positions. You can also give the judge few-shot examples so it learns exactly what a fair verdict looks like. And for math, you just provide those reference guides so it doesn't get tangled up in complex logic. Section 6. The final verdict. Do AI judges work? So, having accounted for all those wild biases and implementing the SAFE framework, do AI judges actually work? So the crucial point is this. When you use a top-tier model like GPT-4 as a judge, its verdicts match human expert preferences over 80% of the time. To put that into perspective, 80% is the exact same agreement rate that human experts have with each other. The AI judge is literally indistinguishable from a human consensus. But wait, because here is the ultimate plot twist. What happens when the humans and the AI judge actually disagree? Well, researchers took a random subset of 100 cases where human fact-checkers and the SAFE AI judge completely disagreed on a fact. When they investigated, the AI judge was actually right 76% of the time. That means the machine was fact-checking more accurately than the human experts were. Which leaves us with this really provocative question. We originally started doing this just to find a faster, cheaper way to grade AI, right? But now, we've essentially proven that AI can seamlessly approximate human preference and even beat us at rigorous fact-checking. So if we truly understand how LLMs judge human preference this effectively, what do they really need us for going forward? It is a massive question about the future of AI alignment. Thank you so much for joining me for this explainer. I hope it gave you a great framework for understanding how AI is stepping into the judge's seat. Keep questioning everything, and I will see you next time.